Wouldn't it be nice if there was a free VS Code extension which would enable you to see the results of your TypeScript or JavaScript code right inside your editor? And wouldn't it be nice if this extension would also support alternative runtimes like, for example, Bun or Deno? In the last 6 months, I tried really hard to create such an extension, and I'm really excited to show you the results. So let's get started and let me show you the TypeScript worksheet. So let's see how we can use the TypeScript worksheet in VS Code. So the first thing we of course have to do is we have to install it. So we open the extension tab and we just type in TypeScript worksheet like this. And we'll see here we get it as the first result. So we can just install it like this. And now we are already set. Now everything else should be installed by the worksheet itself. So the one thing which you need is TSX globally installed. TSX is something like ESBuild, which will be used to run your TypeScript or JavaScript code. So what we now do is let's switch over to the Explorer so that we can see which files we have here. So the only file you really need is a JavaScript or a TypeScript file. So any file you already have, or you can just create one. And let's see what's in the package JSON. So you can see here there are just 2 dependencies, but they are just needed for my demo. You don't need them to run the TypeScript worksheet. But let's now go into the other code TS. This is just a simple exported function we will use later to import in our index.ts we have here. So let's switch over to the index.ts file and let's get started. So why should we use the TypeScript worksheet? Well, the TypeScript worksheet basically helps you to see what the result is of your code without having to use like the terminal and console log. Let's say I have a date here and I want to see what this toIso string here does. Now, prior to TypeScript worksheet, what I would have done is I would have wrapped this in a console log like this, and then I would have printed the result in the terminal using something like tsnode or, for example, tsx. Now, the problem with this is that it really stops my flow of programming because sometimes I just want to see like what is the result of this and what should I use. So this is why we can now use a TypeScript worksheet. So what we can do is basically we can just remove this console log because we don't need this. And now I can open the command palette and I can use run TypeScript worksheet. So when I run this, we can see we get the result at the same line as we've written our code. So we can have it right inside our editor. And this makes it much easier to work with. Now, what you also can do, of course, is we save this in a variable like this. And let's save this here and run this. And we can see here, this also works for variables. But sometimes you don't want to have the result of all the variables. For example, you only want to have the result of your expression you have like this. And this is when we can use run TypeScript worksheet without variables. When we run this, we can see it only shows the result of our expressions. But we can restrict this even more. Let's say we have like 2 calls here. Now, because I want to do something with substring here, 5 to 10, for example, and I only want to have the result of this line, I can use the comment here with a question mark. And when I now run this again, we can see I get only the result of this single line. This makes it really easy when you have a huge file and you only want to have a single output. You can just specify it like this. Of course, you can make this for multiple lines by using it like this and running your code. And you can see now we get the output from line 4 and 5. So really easy to have an output of your code without having to leave the editor. Now, of course, you could always run this from the command palette like this. But of course, what I would do is I would create like a key map to just run this command by using the keyboard. So for example, I use the shortcut command and dot to run this code. And so I don't have to open command palette all the time. Now we can make this even shorter by saying we add a TS worksheet at the top of our file. And because of that, every time I save the file, the code will get executed. So as you can see, I got the result even when I just saved the file without running my command manually. So we can also use with variables here so that it also prints everything which is defined from a variable. So like this, we can see we also get the date here. So this works fine too. If I don't have the suffix, it will only print like when we would run without variables. Now this brings some really cool features which we could use. For example, what we can do is let's remove this here. Let's say here we have an array, and this array to start with is just an array which is empty and has a length of 10. Now sometimes we don't know what's in there when we just create an empty array. So let's save this and we can see it creates an array of 10 elements which have all the value undefined. Now what we do here is we can say array dot map, and we can immediately see what happens when we map over our array and use, for example, our index. So when we save this, we can see we get the result from 1 to 9 in a new array. And this makes it really easy to work with JavaScript or TypeScript code and to see immediately what the results of your actions are. Now, what we also can do is we can just hover over the result here and click copy. And this now is copied to the clipboard, and we can just paste it anywhere and use it like we want. So for example, in here, we can just paste it in here, and now we have the code from our result from the TypeScript worksheet. So really cool to work with this, in my opinion. Now, of course, you can't just work in this one file. You can also import your own code. So let's remove this here. And what we can do is we can say, for example, we have this hi there, and we can see here this comes from this other code file, this other code TS file. Now we can import this and now run our code, and we can see we get the result here, hi there. And when we check what's inside, we can see this just is a function which returns the string hi there. So we get the result from this function call right inside our editor. But of course, you are not restricted to running your own code. You also can import code from node modules. So we have here our node modules with an Axios installation. So we can say here we have an Axios here, and we import this here from Axios, as we know, and then we use, for example, HTTP google.com like this, and then we have a then, and we say result.status like this. Now, when we save and run this, we can see here that we don't just get the promise, which is still pending, but we get the real result we have from this call here to our status. And what we of course also could do is we could use async await. So we can say we have our data here, and we say await axios.get, and let's remove this here. And now we can just say data.status like this, and we can run our code, and we can see we get the result here too. So you don't have to worry about how to use async await. You can just use it as you want, or even on top level here, because the TypeScript worksheet will take care of resolving the issues, how you can use async await on top level. Now, but let's see again how this works with promises here. So we have this promise here, which we run, and we'll then get the status here. Now, let's say we have a console log here where we say hi sync. And when we now run this code, we can see here, first, of course, we have hi sync, and then we have resolve promise 200. Now, in this case, we don't see the order where the code gets executed. And this is where also the TypeScript worksheet can really help you, because what we can do here is we can open here the time travel option of the TypeScript worksheet. And what this now offers us is this here, show order. When we click it, we can see here with the numbers what was evaluated first and what was evaluated last. So we can even use this slider here to slide through the results. So at the start, there is nothing there. Then first console log was printed out, and second, we can see the resolve promise here. And this really helps us also to understand when we have issues with asynchronous code, to see what gets evaluated first, for example, when we use micro tasks or when we have like callbacks from web APIs. So I really like this approach, so that we can use the time traveling options to see what happens. Another cool thing of the TypeScript worksheet is that we are not restricted to wait until a file is done loading or is done finishing all its tasks. So what do I mean with this? So let's remove all this and let's create a set interval here. So what we now can do is we say we want to wait for 1 second between each interval, and then we say console log here I++, and we say we have here an index which starts with 0. Now when we start it, we can see that as long as it's still loading new content, we immediately see the results of this. So we don't have to wait until our file is done. We can just leave it running and can see the results as they are coming in. I can just stop this using stop current here, and now we stopped the run of our application. But we can see here we have everything in there which was created here during the time when the file was still doing its tasks, its background tasks here with the set interval. And you can do exactly the same. For example, if you have a server you keep running, then you can also check what happens when the server is running by using the TypeScript worksheet, by just starting it with this worksheet and then seeing what kind of requests come in and what happens with them. Now, another cool feature I'm really proud of is that also multiple runtimes are supported. So not just Node.js, but also Deno and Bun can be used to run a TypeScript worksheet. So let's remove this here, and we can now switch this to Bun, for example. And the only difference between running Node or running Bun or Deno is that only Node.js supports ongoing results. So with the set interval, this only works with Node.js, but everything else also works with Bun or Deno. So I can now say, for example, bun.fetch like this, and I can then say http/google.com, and we have our then our status like this, and we can just run our code and we can see this works just fine and we get back a 200 result. Because we switch to the Bun runtime, we of course have access to Bun itself. The same you can do with the Deno runtime, and you then have access to everything which Deno provides. The only thing you need to have for Bun or Deno to work is you need to have Bun or Deno in your path. So when you open, for example, your terminal and you run which Bun, for example, you need to have this in your path so that the TypeScript worksheet can pick it up. But this is the only thing you need, and you can do the same stuff what I've shown you prior also with Bun or with Deno. So thank you for watching the video. I hope you find this extension useful. If you do, please share it with your friends and coworkers, and also let me know either in the comments or on GitHub if there are any issues with it. And if you liked the video, please leave a like and subscribe to the channel to stay up to date for the newest TypeScript stuff. See you soon in the next video. Bye.